So we are going to be talking about the work that we've been doing, trying to get a CDAF framework set up so it can start being used by, well, everybody at the end of the day. So the team that's been working on it is led by me, although I actually do very little work. Prasenjit and Rishi, who are the ones who've been actually doing the work over the last couple of years, and then Jean-Francois and Ed Jean-Francois did some work a couple of years ago to try to use Felix to set up match-up databases. So we have that, or at least an initial version of that set up. And then what we've been looking at is trying to get the software to use that data to create the CDAF statistics. So I'll just quickly go through what the CDAF is for those of you who can't remember, because it's been a while, and then Rishi will take over for me when he talks about the work that's been done over the last year or so. So the CDAF is the Climate Data Assessment Framework. This was something that was introduced in Tokyo, I think. Chris and Gary and I put together the document. And the idea is it's a framework where you can try to assess the different SST data sets from the point of view of their usability for climate. As many of you will remember, no doubt, we spent a lot of time explaining at the time that this is not meant to be a competition. It's just meant to provide the information that the user can use to assess whether or not a particular data set is to be used for their application. And in no way were we ever going to label a data set, yes, this is a climate data record, or no, this isn't. This is more just about information. So as it says there, it's meant to support users in their selection, and it will provide, hopefully, authoritative statistics which will be reviewed in terms of to make sure that everything is in line with the methodology. The task team has been existed for a few years now, although I will admit that everybody on the task team has been extremely busy doing other things and generating salary and all that kind of boring stuff. So progress, I will admit, has been slow, but the point about this presentation is just to tell you that we haven't forgotten, that we are still moving forward, albeit at a snail's pace, or maybe slightly faster than snails. Is a tortoise faster than a snail? I guess it is. So we have made progress this year. And the last report that I gave was about the work that Jean-Francois had done on the matchup data set, and this is about what we've done in terms of the software. So the CDAF is split into different sections. It goes from the data and generating the data to the statistics through to a report that is assessed and then is finally published. So from that point of view, it's quite simple. And the metrics are all detailed in the CDAF document. They, again, are relatively simple. So we have means and we have medians and we have robust standard deviations, and there's an element of trying to sample the data set in a more regional sense, 10 degree by 10 degree boxes, for example, so you can see how the different data sets are working on that sort of scale. Also, of course, there will be an assessment of trend and trend uncertainty. And if the data exists, which for many data sets it doesn't, but for some it does, there's also metrics related to SST sensitivity. So, and of course, you can split things into random noise effects and also systematic effects. So all of this are the metrics. They're not that difficult to generate, but you just need a framework within which they are all calculated systematically, irrespective of the input data set. And in the document, we described a form where you would put all of this information. Of course, now we intend to do all of this electronically. So this is basically just showing you the information that we would intend to populate. There may indeed be an online version of this form that gets automatically filled out, but the important thing is the information that goes into it to be used in the assessment. And our work plan has been to set up something that will generate the reference data, the matchup data sets, then produce the matchups themselves, then create the statistics in a work package, and then provide the output that is then assessed, as I said. And Prasanjit, as Prasanjit is Mr. Web SST, it would seem these days, or at least actually for quite a long time, in fact. He has thought a little bit about the workflow design for the web interface. This was shown in the previous time I gave this presentation. The bit that we've been concentrating on over the last year is the bit that's in yellow, so just about the coding, not about the web interface. And I think it's now time to turn over to Rishi.
Okay. Hello everyone, this is Rishi Kumar Gangwar from Space Application Center, ISRO Ahmedabad. A very good evening to all of you. Since John has already provided an overview of CDAF and its responsibilities, so I'm not going into the details of the CDAF again. So I'll be focusing more on the code conversion part, which we have been doing since last few months. So here is a table which shows you exactly what we could achieve during the last few months. These ideal codes was actually written by Gary Corlett, and we are now following those codes in order to convert into the Python notebooks. So here we have converted two codes. The first one is this CCI val plot master time series. This code actually provides the statistics for two main systematic and non-systematic effects, which John has already discussed. And the other program deals with the stability of the data set, which deals with the degree of invariance over the time of the error with respect to buoys, global tropical mood buoy arrays. So this is to just show you the how because, and one more thing, we haven't changed the name so that there should not be any confusion. So we keep the name of the programs intact. Only the this prefix or the suffix is the different. The PRO is for ideal code, and this IPNB is for the Python notebooks. So in this part, the left hand side of the table shows you the programs written in the ideals. This main program is using many subroutines and functions, whereas we have also written the same codes, but we haven't written the codes in different in the next code, but we have this Python notebook includes all these subroutines and functions in this. So now the next slide, just show you the glimpse of the how the Python code and ideal code looks like. So here this left panel shows you the a function of which actually fitting the linear curve written in the ideal code, whereas the right hand side of this is showing the corresponding Python code. So you can see almost because this syntax is a little bit different, but the number of lines you can say more or less same for executing this trend line fit. So here this is to just show you the how this new codes is performing with respect to older the ideal codes. So in the left hand side we are showing the output of the old ideal codes. This actually shows you the histogram of the robust standard deviation of the this ATSR L3 data versus the drifter buoys. Whereas in our in Python we are showing the ATSR E1 and E2 L4 versus drifter. So these histogram may not be because they are different data sets. So there is no comparison in between them, but we are just showing that that we are able to achieve the same output from the new Python codes. So this is just to show this. And in addition, we have also included some statistical parameters in the plot itself, so that it can give you inference about the data which you are already validating with the reference data sets. So here, and the left arrow and the right arrow in both the plots are showing the data points lying outside the 4 times of robust standard deviation. So now, and this in the green, the statistical parameter written in the greens are the robust parameters. Now, again, this slide shows the output from the second code, which deals with the stability of the CDR data version 2 with respect to GTMBA, that means global tropical mode buoy arrays. So here, this is the time series of the error of the ATSR, AVHRR, as well as analysis L4 product with respect to GTMBA, starting from the 1978 to 2018. So the same output we are able to generate from the new Python codes. So this is the corresponding code from output from the Python code, which we have converted from ideal. So here you can see the same type of output we are able to achieve. And if you see this, the third one, the analysis, if you compare from the ideal and the Python, the exactly same output we are getting, but there is a slight difference between these two, because the input data, the ATSR and this AVSR data is different from that earlier version. Now, in the next year or so, we will be focusing more on this ideal to Python conversion, which are still left for us. And once we have, we'll be converting this whole ideal code to Python. After that, we will be moving towards the interfacing of this new code with the Felix generated MMD's data. And after that, we will do the analysis part. Once this is all over, we'll be focusing more towards the development of the web-based portal for this CDAF framework. It's all from my side.
All right. Okay, great. Thank you so much, John and Ashley. I think we can open this presentation for questions now. Let's begin with online participants, if there are still any. Are there any questions from online folks?
It seems not.
Seems not. Okay.
Yes, we got one.
We got in. So I think we need to stop sharing first, because I cannot see who is there.
Just would like to. Sorry.
Yeah, go fire away a question.
Yeah. Can I?
Yeah.
Yeah, we can hear you.
The code you are going to share, or what is your plan to for this change of code?
Try to repeat the question. I think they didn't get it. There was an echo.
Yeah, say that again, please.
Okay. Now, yes. What is your plan to share? Are you planning to share the code, the Python code you are going to develop?
Yes, I will let John answer that.
Absolutely. There is, yeah, it will be completely open source, of course.
What's your format? You are going to use GitHub, or where are you going to? What's your plan to share the code? How? I mean, a Jupyter Notebook way, or you have a Git to do so? What is your plan?
Just if you repeat that when I'm in front of the speaker, I might be able to really catch all of the words you're saying.
Yeah, we can hear some echo actually. You are going to use Jupyter Notebook in this way, or you're going to share the code in a Git? What is your platform to share?
Yes, it will be Jupyter Notebook and Python routine regular scripts as well that could be called from your Unix scripts.
Okay, thank you.
There is another question with Andy.
Andy, fire away.
Yeah. Not specifically about the CDAF, but that plot for the stability the stability plot that you had. Maybe you should put it up. Can you do that? Or have you got rid of it now?
We stopped sharing, but I think we remember the figure.
Well, basically, what I was going to say is for the L4, I just noticed this significant dip in 91, which I assume was the Pinatubo eruption. Is that correct?
Yeah, that is okay. That's a good question. We assume it's correct, but for now we are just replicating what has been done. But there might be some more experiment that we'll do with the trends, especially we've done some work with trends already. Okay. Does it make sense for now? Let's assume it's correct.
Yeah, that's fine. It just was like, because there was ATSR available, although I don't know. I'm not exactly sure why it would have kicked in there if you have ATSR available. Maybe you don't have it right for the very start of the mission. Maybe that's the problem.
In 95 percentile, I'm also not 100% sure what does that mean. I guess they filter the data, the tells, and then make a linear fit something and giving the slow value. That's what I assume. But for now, we are just replicating what was in the ESA CCI project, and eventually
right. I mean, it's more a question. It's therefore a question for maybe John.
Yeah. What I'd say is that, I don't know why it would be a question necessarily to me, but
because you're a Reading representative on the spot.
Well, Chris is here as well. I don't know the answer to your question. All I'd say is that the CDAF is there to provide comparisons between different data sets. If there are problems in individual data sets, it would be highlighted by the process, but not necessarily, it's not designed to tell you how to fix it.
No, I agree, but I'm now doing exactly what I'm highlighting it by looking
exactly.
At it. So what do you say, Chris?
I see Chris slightly laughing.
Yeah, that's good. That's good.
Yeah. Well, I think you've already answered it, and the Pinatubo went off in May, and ATSR data are available from August. So
okay.
The dual view retrievals don't kick in until several months after Pinatubo, and AVHR in that. I mean, those were previous versions of CCI data as well for replication.
Okay, fair enough.
So the sensitivity's gone down, but yes, there was still some sensitivity then. I do have a question, if I may.
Okay.
Which is there still engagement from people with long-term data sets about getting this done once you got your code ready? Are we still engaged with the people who provide long-term series?
No, not at the moment, because I don't think we can really engage until we have something that they can look at. So when we get something that will generate matchup data, and I mean, this code will be operating to some degree before that happens, and then we can say to them, please try this out. And we have a forum for it, which is this group, right? So we go to the IC tag or whatever and say, we've now got this system set up. Can you please get everybody to at least have a look at it to see what they think? And until we do that, what can we engage with them apart from coming to GRIS meetings and saying what we're doing, and probably say to all the level 4 producers who are online or in the room that within a couple of years we will be coming to you to say, would you like to try it? And we'll probably pick some people before that to trial what we're doing to make sure what we're doing is sensible. For example, Helen or Lavi. Yes.
Thank you.
My question is this code only for level 4 products, or could it also do a level 3?
It is meant to be for something that people think might be a climate data record. If you have a level 3 that you think could be used as a climate data record, then it should be agnostic to that. The only issue that we're going to have, the only issue we'll have is we'll have to think about how to deal with gaps in the data relative to the statistics.
Oh, yeah, okay. So it really is designed.
Well, no, we haven't designed it at that level yet. So I mean, there should be no reason why it couldn't be, as long as the data set is something that could be used as a CDR.
Yeah.
But there are some things we would have to think of specifically for the non-level 4 cases.
Interesting.
And by no means this is the final version. As far as I know, it doesn't. As far as I know, it doesn't actually make any geospatial characterization. It's more like you create a matchup and then come up with some stars. So I don't know. Maybe there is some geospatial variation, but if not, then that's something one has to think and extend to.
How many years does a data set need to be a climate data record?
Good question. It's language frequency.
I mean, as I said, the idea of the CDAF is not to say yes, you are a climate data record, and no, you are not. The panel that will review the data set may say 5 years, we don't really consider it to be long enough for a climate data record, but we're not going to be definitive and say we are only going to be looking at data sets that are 20 years plus.
Yeah, because a lot of sensors haven't been around for very long years. You know?
Indeed, and it depends on what you're trying to measure.
Yes.
So I would say that there is no definitive time, but it will be used as part of the assessment process, no doubt.
Can I add? So
yes, of course.
If I may just add, John, here, if we are talking of at least a decadal variation, then it should be 20 years as per the Nyquist frequency.
Well, indeed, but in the CDAF, there is, I think, if I remember rightly, there is a recommendation for a minimum time.
Yeah, must be.
Yeah.
I'm interested.
Well, no doubt.
One question from Igor. Been quite waiting for asking a question.
Good morning, Igor.
Yeah.
Or afternoon.
Morning or afternoon on our side. Hi. So thanks. One question you discussed about matchups, and did you already discuss where you will do the matchups for this activity? Because on our side, on the matchup-based task team, we also preparing. We will be delayed. Jean-Francois will present a couple of days, but
yes. So the idea is, I mean, it's explicit in the task team to talk to the matchup task team as regarding what the matchup task team is generating. As I said, the statistics that we're at least initially going to provide are based on what should always be in a matchup data set anyway. I mean, that would be something for further development in the sense of if you're talking about extra metadata that could be used, then at the moment it's not in the current plan, but this is not something that is envisaged to be a black box. We write once and never touch it again.
Okay. So there'll be some exchange of information.
There should be. And we were kind of thinking that given that Jean-Francois is on this team and on your team, that would be the natural route to go through. But,
yeah. No, I fully agree. Yeah. Okay. Thanks.
Are there any further questions in the room or online? That would seem to be a no for some of it.